Bismillahirrahmanirrahim. Okay, Walid, to understand this, to grasp this integration of the trigonometric functions, uh, you need to remember that this differentiation and integration, these are the reverse processes of each other. Okay? So if you remember that the derivative of sine ax plus b, that was cos of ax plus b times a, then you should remember, then you can learn that the integral of this cos ax plus b would be sine of ax plus b over a plus c. This a is the derivative of uh, this angle over here. Like if I exactly write this as the integral of a cos ax plus b, you will see that this would be the integral of a cos ax plus b would be a sine ax plus b over a, and these a's get cancelled. Okay, and you get this sine ax plus b back, and then we write a plus c. Then we have the derivative of cos of ax plus b. So the derivative of cos of ax plus b is minus sine ax plus b times a. So if you integrate the sine of ax plus b, you get minus cos of ax plus b over a and then plus c. Now this is really confusing as you see that the derivative of sine is cos and the derivative of cos is going to be minus sine. But when you integrate cos, you get sine. And when you integrate sine, you get the minus cos. So just be careful about this. Okay? Then you have the derivative of tan ax plus b. So that is a secant square ax plus b. Therefore, when you are going to integrate the secant square ax plus b, this would be tan of ax plus b over a plus c. So you need to remember that whenever you have to integrate, integration is going to be, you're integrating the trigonometric functions. So just remember you can only integrate sine x, you can integrate cos x, and you can integrate secant square x. You have direct rules for these integrations. This is minus cos x plus c, this one is sine x plus c, and this one is tan x plus c. If you have any other thing other than this sine, cos, and secant square, then you will have to think of some other uh, connected or required techniques to be able to integrate. Like you will see that when you have to integrate this tan x, so you cannot integrate this directly. You will have to write, look, you have done this previously, the integration where you get the result as an integral. Look at this. If you write this as sine x over cos x, okay? So it is going to be a rational function now. Instead of moving this cos x to the numerator, you see that the cos x derivative is minus sine x. So you multiply it with a minus twice, okay? So the integral of tan x is going to be minus ln cos x, okay? Similarly, suppose if you want to integrate tan square x, I'm giving you some easy examples here. So you will have to write this tan square x as secant square x minus 1. And then you can integrate it. The integral of secant square x is going to be tan x. This is minus x, and then you have plus c. Okay? So please remember, you can directly integrate only to the sine, cos, and the secant square. Otherwise, you will think of some uh, manipulations to be able to integrate these trigonometric functions. Okay? Now let me take you to the exercise where you will practice some questions from here. First of all, you will be trying some easier questions and then you will be going towards the harder ones. So here are the questions that you can try mentally. Okay, you look at these questions and I'm coming back to ask you about these integrals. Now, what is the integral of sine 3x? Minus cos
minus cos
3x over 3 plus c. Okay, the integral of 3 sine 2x is minus 3 cos 2x over 2 plus c. The integral of 2 cos 1 minus 5x is going to be 2 sine 1 minus 5x whole over minus 5 plus c. Okay? Integral of cos 4x is going to be sine 4x whole over 4 plus c. Integral of 5 cos 3x is 5 sine 3x over 3 plus c. The integral of 3 sine 2x plus 1 is minus 3 cos 2x plus 1 whole over 2, and then you have plus c. Sine x by 2. Chalo, ab bolo, sine x by 2 is?
sir
Minus cos
minus
x
cos
by
x
2
by 2 over x by
over
2
half, that would become minus 2 cos x by 2 plus c. Secant square 2x,
sir tan 2x over 2
yes, and 2 secant square 5x minus 2,
2 tan 5x minus 2 over 5
yes, 2 tan 5x minus 2 over 5, and never forget to write this
plus c.
plus c. Okay, now let's try some these limits things here. For these limits to be applied, you have to remember those typical values of sine, cos, and tan. Okay, so this is, so you have, first of all, cos 4x dx. So this 2a would be limit from 0
Sun
to pi by 6. So you have sine 4x by 4. I'll be writing this by 4 outside. So this is sine 4x. So this is quarter into sine 4 into pi by 6 minus sine 4 into 0. So you have quarter into sine 2 pi by 3, and sine 0 is 0. Okay. Sine 2 pi by 3 is same as sine pi by 3. So that is quarter into under root 3 over 2. So that is under root 3 over 8. Okay. Look at this f part. You have to integrate limit from minus pi by 4 to pi by 4. This is 5 minus 2 secant square x dx. This is minus pi by 4, pi by 4, 5x, and then you have minus 2 tan x. Okay? 5x minus 2 tan x. So now we apply the limits. This is 5 pi by 4 minus 2 tan pi by 4 minus 5 into minus pi by 4 minus 2 tan of minus pi by 4. Okay, so you have 5 pi by 4. Tan pi by 4 is 1. So this is minus 2. This is plus 5 pi by 4 minus into this tan pi by minus pi by 4 is basically minus 1. This is plus 2 and this is going to be minus 2. Okay, so you have this 5 pi by 2 minus 4. And you can write units with this. Okay, so that is how you integrate and then you apply the limits to these. Okay, would you like me to try this question number 3? Okay, let's see this. In this third question, this is basically a question on the reverse substitution. You have to remember your differentiation with this. You see that he says find the derivative of this. So when you differentiate this x sine x, so this derivative of x sine x plus cos x is going to be, you will apply the product rule here. So this is x sine x. First of all, this is sine x. Then you have x cos x, and then this cos x derivative is minus sine x. So these are cancelled. So this derivative of x sine x plus cos x is going to be x cos x. Okay? And then he says, hence find the exact value of this. You see, this is a product here. Walid, you cannot integrate this directly. So there are some special things given to you, some extra information, like he has asked you to differentiate in the first part, and then he's asking you to find this value. So you can say that if the derivative of all of this is this, then you can say that this implies that the integral of x cos x is going to be x sine x plus cos x. Okay? And since you have to apply the limits here, so the limits are from 0 to pi by 3. So we put the limits here from 0 to pi by 3. Okay? So when you put the limits, please be careful of this 0. Sometimes we think that when you put the 0, everything is going to be 0. But be very careful in case of cos x and e raised to power x, because cos 0 is 1. Okay? So this is going to be pi by 3 cos pi by 3 plus, sorry, this is sine. We have sine here. And then you have plus cos pi by 3, and then minus. When you put 0, 0 into sine 0 is 0, and cos 0 is, let me write it as cos 0. So this is pi by 3, sine pi by 3 is under root 3 over 2, and cos pi by 3 is half, minus cos 0 is 1. So you have pi under root 3 over 6 minus half. That is its exact value. Okay, Mia. Now you can practice these questions from this exercise. This is your exercise. I think this is 5C, exercise 5C. Okay? You better start this from question number 1 and then you go on.